This topic works with the general forms of parent graphs. So this is primarily about solving for the stretching factor. So we're going to apply still the same rules that we do with parent graphs. We got to look for the transformations, the shifts left and right. You don't have to be worried as much about flips, except for realizing my answer should be a certain form, because we're going to solve for the stretching factor in each case. So first thing we want to be aware of is make sure you do know all of your parent graphs. Now recognize y equals x squared, x cubed, 1 over x, 2 to the x, absolute value of x, and square root of x. You have to recognize all of those parent graphs in order to be able to do this kind of a problem. If you have problems, look at the previous video. Our general forms, again, they're going to be the same structure, realizing that a is my stretching factor. That's what we're going to solve for. The h and k, the k shifts the graph up and down, and h shifts the graph left and right, but it works opposite. Okay, so what we're going to be looking at is solving for that stretch factor. So we're going to put these ideas together. So in this first example, we could tell that we have y equals absolute value of x. That's my parent graph. And then the next thing I'm going to look for is how it's shifted. Well, I could see it got shifted to the left 3 and up 6. So that helps me to build part of my equation. The a part I'm going to figure out in just a second. So I got y equals a times the absolute value of x plus 3. And remember that when we do a shift left or right, it works opposite. Because if I take positive 3, I put it in left 3, it'd be a negative 3. That's my vertex. My vertex is at negative 3, 6. If I plug in negative 3 into this equation, I get 0 in the absolute value. That's why the shifts left and right go opposite. I'm going to solve for my a value, so I need a point. Well, here's my point. It's y-intercept at 0, 4. So y equaled 4. I plug in the 0 into x, the 4 into y, and now I'm going to solve it. And because I know it's flipped, I know my answer should come out to be a negative. If it doesn't come out to be negative, I may have plugged in backwards. So that's kind of a clue. So I subtract 6, I get negative 2, divide by 3, so a equals negative 2/3. Last step, plug in. All there is to it. So it's really just a little extension from working with parent graphs. Okay, and this other one, recognize a parent. Well, it's half a parabola. That's a square root graph. So I look at where it starts. I can see that first of all my parent was y equals square root of x. And I can see that I went to the left 4 and down 1. So again, I'm going to go and start with this. Now the other part is I'm going to use this point, and that point was at 5, negative 7. So I need a point that it goes through, so I'm going to use that as well. So here's my general form for my square root that's been shifted. X plus 4, again we worked opposite from left 4, because my locator point was negative 4, 1, negative 4, negative 1. Now I'm going to plug in these values. So y negative 7, x is equal to 5. Plug in 5 plus 4 is 9. Square root of 9 is 3. So I got 3a minus 1. Add 1 to get negative 6. Divide by 3. Get a equals negative 2. And our last step, boom, we just plug in negative 2.